Interference, okay, occurs when two waves overlap each other and form a new wave, okay? New wave only exist while waves overlap, all right? So, if you have two waves going on together and they overlap into each other, then that is called an interference, okay? So, a constructive interference is that the waves add together, so the crest of two or more waves arrive at the same place at the same time, and then they're considered in phase. All right. Destructive is when waves subtract from each other. So that occurs when the crest of one wave meets the trough of another wave. All right. And that will decrease the loudness. Okay. And that's considered out of phase. So I'll say that, but then, you guys may not understand. So let's talk about this. Let me show you guys a picture. All right. Let me draw something on here. All right. So on here, all right. You have two waves meeting. So a constructive wave, okay, is going to be one, that's your first wave, and then your second wave is just going to add on to that, okay? And it's going to make that louder. And that's because that's two crests are meeting and its two troughs are meeting at the same place. So that means that they're going to be in sync with each other, okay? But when you have something that's a destructive wave, okay, you're going to have your first wave right here, and then your second wave, all right, is going to be the black one. That's going to end up being like this. All right. And these two are going to cause interferences with each other, which means that you won't hear it as loud as you would if there was only one wave, okay? So hopefully that makes sense. All right. So, um, here's a little challenge question. Okay, so draw a diagram, okay, of a constructive and destructive interference. Include labels such as crest, trough, node, wavelength, and amplitude, okay? So, hopefully this will help show you guys. And as you can see here, we've got my circle here is showing that these two are causing the disruption, and then these two are working together congruently in order to make that amplification happen, or vice versa, that cancellation happen. Okay. All right. So the next thing we're going to be talking about is refraction and diffraction. All right. We're discussing lights. Okay. So when you have refraction, that means that it will cause the light to bend due to the change in the wave speed as it moves from one medium to another. For example, placing a pencil in a glass of water. All right. And when you do that, you'll notice that the pencil looks a little bit different, okay? That's how the lens focuses on the light. So I want to show you guys something real fast. All right, so this is a PhET lab, okay? So basically what I'm doing here is that I've got my little laser right here. You can move your laser, okay? And then I'm going to send it through a medium. So it's going to be air versus water, okay? This part right here is the water, this part is the air, okay? So as I'm going to shine this light, all right, you're going to see how when it hits the water right here, okay, you're going to see that reflected light, the refraction going in the opposite direction, okay? So if we move it, okay, you move it at a certain angle, they're actually going to meet, okay? But you can just have it going like this, and depending on what medium you're going through, it will change how it's going to reflect, okay? So if you have water, okay, but what if you have glass, okay? So you have glass and then you have, let's see, water. And you guys, if you want to play around with this, okay, this is on PhET Labs and it's just bending light, okay? So you guys can take a look at that if you're having some difficulty imagining what's happening there, okay? But we head back to here, so refraction versus diffraction. So diffraction will cause a wave to bend and change direction. Amount of diffraction depends on the lambda, okay, compared to the obstacle's lambda. Okay, so the flashlight, if you flash a flashlight onto a mirror, okay, and the reason why the letters are written backwards on an ambulance, okay? So white light works kind of in a different and a little bit of a confusing way, but if we can think about other ways to, actually describe it, then it becomes much easier for us to quantify, okay? So refraction, all right? So it's important because the idea is that we need to understand where your actual like when you shine a light into something, you need to understand that the refraction of what you're seeing is going to be different than like where you shine the light originally, and that's just depending on what surfaces you're showing into everything. Okay, so let's continue to take a look at these. You can take a few more seconds on this slide if you'd like. Okay. So, diffraction of light through two gaps, okay, the dark bands of where the crest of the wave cancels out due to the trough of another. All right, diffraction of water waves at a bay. Okay, so let's take a look at this one. All right, so a wave reflection, all right, occurs when a wave strikes an object and bounces off of that. Okay, all types of waves can be reflected. All right, so looking in a mirror reflects light. All right, echoes reflect sound. So your law of reflection states that the angle from the incident beam to the normal equals the angle of the reflected beam to the normal. All right. And what does that mean? If we remember back when we were talking about forces, okay, that normal force is the force that the wall or something is applying back to you when you apply that force. All right. So our source of our light is going to hit the object, and the angle of incidence, all right, it's right there. So the law of reflection states that the angle from the incident beam to the normal is equal to the angle of the reflected beam to the normal. All right. So your source goes to the object, and then your normal. All right, and then that object is going to reflect back. Okay, the angle reflected, and then the still have the normal in the same spot. Okay, right. So looking at a couple of examples too, okay? So reflection. So we have a single plane, all right, single ray reflecting from a plane mirror. Okay, so you're gonna have your incident ray, okay, or the ray that you are shining onto the mirror, okay? And then it's going to reflect back, okay? So it's going to make kind of a V shape, okay? And then your normal is just going to be that line cutting through, all right? So then your angle of incidence or the angle of your original light is going to be the same as the angle of your reflection, okay? So many light rays reflecting on a mirror, they're all doing the same thing. Many light rays reflecting through a rough surface, it's going to be a little bit different, but this law is still going to remain the same, where the angle of the object normal lines, that angle measurement is going to be the same as the reflected and your normal. All right. So reflected image is laterally inverted, and you guys have seen this before, where you have if you're looking at something inside a mirror, it is flipped laterally, right? It is reflected. So if you have a word inside the mirror, all right, when you look at that mirror image, which is where the word mirror image comes from, okay, it's going to be flipped. Right. So, how can we see reflection in a plane mirror? All right, so the image appears behind the mirror at the same distance as the object. All right, so you're going to have your real light bulb shining into the mirror, all right? And then through the mirror, through its reflection, you're going to see, all right, the reflection of that object. So, diffusion of light rays from a paper's surface, no image is going to be seen behind the paper, okay? It just matters what you're talking about when you're talking about, you know, the objects in the medium that it's running through. All right. So light through a concave and convex lens. All right. So a convex lens has a surface that curves out like a spear. All right. So this spherical shape, and it creates a focal point where light travels through. All right. So this concave lens is going to have all the light rays go through it, and they're going to create that focal point at the end. All right. A concave lens has curves like this, and they're going to send that light outwards. All right. So the light will end up scattering as it passes through. All right. So we're going to, ask you guys a few questions so that you guys can go over some of these, concepts of light, as well as I'll find some videos to help, reiterate some of these points. They're a little bit confusing, and I know that, but hopefully you can get the hang of them.